Okay, so Year 8, Lesson 4, Resistance. So what resistance is it's how hard is it for electricity to get round a circuit. Okay, so if you imagine that you're running and you've got a rubber band tied to you, well, the resistance of that band will slow you down from running. And the more resistance that rubber band applies, the slower you go. Well, the same is true for electricity. So if you remember, we said that the cell or the battery, they provide the energy. Let's say, for example, it's 9 volts. And then remember, we said that the current is how much electricity is flowing through the circuit. So the easier the circuit, the more current you will get for each bit of voltage that you put in. Okay, so for example, this circuit here, this circuit would be a really easy circuit because there's just a wire. It's not doing any work, so that would have a really low resistance. So the current on this one would be something along the lines of 8.999 amps, for example, because you're getting nearly the same amount of current as what you put in as voltage. You haven't lost much yet, okay? But if you put a light bulb in, well, that makes it harder, okay? So that increases the resistance in the circuit. So if we have a look at that with a light bulb in. And now, if the voltmeter if the ammeter reads 4.5 amps, then we know that the resistance of the bulb, well, you're getting half as much through now, so that means it's twice as hard for the electricity to flow. So therefore that means that it has a resistance of the bulb is 2, and the units, because that's telling you it's twice as hard for the electricity to flow around now, ohms, because that was the guy who discovered it. It was a guy called Ohm. Okay, so let's say that I put in 2 of these light bulbs now. What's the resistance going to be now? Well, I know that the resistance now is going to be 4 ohms, because this one was 2 and this one is 2. So the resistance will be 4 ohms. And if the resistance is 4 ohms and I had 9 volts, well, last time I said 2 ohms, that halved it. So this time I'm going to say, well, I have to quarter it, don't I? I have to divide it by 4, so 9 divided by 4. Oh, horrible number, why did I pick that? So that would be 2 1/4, 2.25 amps. Okay, so because I've got more resistance, I get less current. And we can write that in a formula. We can say voltage, so that's how much energy you put in per unit charge, equals current, so that's how fast and how many electrons are flowing, times resistance. Because what I'm saying is, I'm saying that the more energy I give them, the more current I will get. But the harder it is for the electricity to flow, the less current I'll get. Okay. And in the next one, I will show you the experiment that we're going to do that tests how to discover how much resistance a component has.